Chapter 3 is all about systems of equations. Systems of equations simply are more than one equation put together in some way, and we're looking for a common solution to both equations. In our case, we're going to only look at systems of 2 equations. You can look at systems of 3, 4, 5, 6 equations, but in our case, we're only going to look at systems of 2 equations. So we're looking for a common value for both x and y, or a and b, whatever the variables are, that work for both equations. That's what we're doing. Okay? Now, on the next couple slides, I'm going to give you all the different steps that we're going to take in order to solve a system for the 3 different scenarios that we'll have. And then we'll look at those 3 examples. So first is the recipe, second is the example. So the first thing we're going to do is understand what our goal is. Our goal is to combine the 2 equations so that one of the variables cancels out. That's why it's called elimination. We're trying to eliminate one of the variables. In our systems of equations, most of the time, we will have 2 equations, there will be 2 variables. We're trying to get it down to 1 variable. That's our goal. There are 3 different types of situations that we're going to run into, and I'm going to outline those 3 things here, because for each one, the process is a little bit different. Okay? The first situation that we have is where a variable might cancel out without having to do anything. And the first example we look at here in a couple slides will be like that. The second scenario is you might have to multiply one of the equations by something to make a variable cancel out. And like I said, this is going to seem easier when we look at an actual problem. But this way, you can keep the sort of steps in front of you as you work through the problems if you can't quite remember what it is you're supposed to do. The third situation, you might have to multiply both equations. Okay, you might have to multiply each equation by something to get a variable to cancel out. Okay, if you don't want to deal with fractions or decimals, okay, which I don't want to do and I don't want you to do. Okay, so those are the 3. You might not have to do any multiplying. You may have to multiply one equation, or you may have to multiply both. And each of the examples that we're going to go through here in a little bit will be one of each of those, so you can kind of match them up. Now, once we've been able to get a situation where we've got variables to cancel, we combine them to get it down to 1 equation. Okay, in number 2a, we just can combine those equations together and a variable is going to cancel out. In 2b, I have to multiply one of the equations by something first, then I combine them together and a variable cancels out. And in the third situation for 2, I have to multiply both equations by something, then combine them together and 1 variable will drop out. Okay, then once you combine those 2 equations together and you get it down to 1 equation, you have this new equation that you need to solve. Yeah. We're going to take that solution for that equation, okay, and you're going to plug it in to one of the original equations. And then solve it for the other variable that we don't know, okay? It says into the first original equations. It should say first. Take a solution and plug it into one of the original equations. Let's fix that. Into
first. Whoa. Okay. Oh, just words. Whoa. They're scary. They're gonna bite us. Some of them are actually about 52.
okay, there, I fixed it. Okay?
Can you connect the in and the 2?
Yeah, it's fine.
No, it's separate words. Take that solution and plug it into one of the original equations and solve for the other variable that you do not know. So on the next slide, it's going to be messed up again, so I'll leave this up here so you get it down right, and I'll fix it after. So at this point, what we've done, we've found what each variable in the equation is equal to. And we write that solution as a ordered pair. Okay, we write it as a point. Okay, I fixed the purple. So again, So now it's right here. Express your solution as a point. Now, we're going to go through 3 examples. Okay, like I said, the first example is going to be the variables are going to be ready to cancel out right away. The second one is going to be we're going to have to multiply one equation by something, and the third example we're going to have to multiply both equations by something. So that's what we're going to go through each one of those. 2a, 2b, 2c, and then 3, 4, 5, and 6 will be the same for both questions, okay? Or for all 3 examples. Here is the first example. Please write this down. This is an example of a system of equations. It's just 2 equations put together, and we're looking for an x and a y that actually works in both equations. That's what a system of equations solution is. It works in the top equation, and it also works in the bottom equation. Okay. This is an example. This is an example of a system where a variable will cancel out right now. Okay. Does somebody see why that is the case?
Yes.
What will cancel right now? Okay, the x's will cancel right now. I'm going to slide this over a little bit. Now, here's why, okay? And I'm always going to add. I know you maybe have been taught that sometimes you can subtract the equations, and sometimes you can, but I am not a fan of that. I'm a fan of always adding. And the reason why this particular problem, the x's cancel, is because I have a positive and a negative, right? And that's what we're looking for. We're looking for a spot where the variable and its coefficient, the number in front, have the same number but opposite signs. And so because those are the same number with opposite signs, I can just add these equations together as they are right now. And then when I say combine, this is what I mean. Okay? So when I have x plus negative x, what does this equal? 0, okay? And so in reality is we don't have to write the 0, but for now I'm going to write it. A lot of times what you will see is a line drawn through them because they cancel out. They get eliminated.
So you don't have to write the 0?
You don't have to write the 0, but I want you to understand why it does equal 0. All right? Now the rest of this, what is plus 2 minus 4?
It's negative 2.
Negative 2y. And then 4 minus 14, or 4 plus negative 14, negative 10. So what I've done, okay, I've done step 2. Now I've done step 3. Okay, I combine the equations together. Okay, I combine the equations together, and I got a new equation that only has one variable. And now I have to solve this equation. So how am I going to do that? Divide by negative 2. So what does y equal? Okay, so I'm halfway done now. I found out what y is. Now I need to find out what x is. So I take 5 and I plug it into one of the equations. It doesn't matter which one. And then I'm going to solve for x. Okay, so I'm going to do this to the right now. Which equation do you want to plug it into?
The
Top one. So here's what it looks like. X plus 2 times 5, because I'm plugging that in for y, and this equals 4. Go ahead and solve for x. So let's check and see if you got the correct answer. So this is x plus 10 equals 4. Subtract 10 from both sides. X equals negative 6. How many got that? Okay, the very last step is to express my answer as a point. Okay, so when I express this as a point, my final answer is negative 6, since that's x, 5 for y. That's how I want you to express your answer. Okay? That's it for that problem. Okay? Here's what you have to understand. For the next 2 examples, eventually we get down to a situation like this where something is going to cancel. That's what our goal is. Our goal is to always get to a situation where one of the variables gets eliminated. That's why it's solving systems by elimination. So the first step in this problem was already done for us. For the next 2 problems, we're going to have to turn it into something like this so that the variables cancel out. Okay? Questions before I move on to the next example? All right. Here's the next example. Now notice here, that the x's are not going to cancel. This would need to be a what for them to cancel? Positive 4, right? The y's aren't going to cancel. What would this need to be? A minus 9. So typically what we do is we turn the smaller number into the bigger number with the opposite sign. Okay? In this case, I have two options. I can turn this into a 4x, a positive 4x, or I could turn this into a negative 9y. And it doesn't matter which one you choose, you should still get the same answer. Since the last problem, we had the x's cancel out, I'm going to do this problem so that the y's cancel out. So in order to turn this into a minus 9, what do I have to multiply it by? Positive 3. It's already negative. And so what happens is I have to multiply the entire equation by 3. And then what I want you to do is that new equation, I want you to write right underneath the second equation. So multiply that out and put your answer right under the second equation. Now, when I do that multiplication, I get 3x minus 9y equals negative 18. Okay? This is my new system. And why this is important is because now I've turned it into the previous problem. Because now the 9y and the minus 9y are going to cancel out. Okay? So why don't you go ahead and try to finish this problem on your own. Let's finish this up. So, what I'm going to be doing is combining those equations together. The plus 9y and the minus 9y will cancel out. Negative 4 plus 3, so I'm adding these together. That's negative 1x. Okay? 9 minus 18 is negative 9. Now I need to divide both sides by negative 1. X equals 9. Okay? Then I take one of the original equations, and I'm going to take the top equation. I'm going to plug that in for x. All right, 9 goes in for x, and now I need to solve that.
Minus the 9.
Okay.
3y.
Okay, hold, please. Okay, so negative 3y equals negative 15. Signs are the same, so I add.
Yeah.
Divide by negative 3. What does y equal?
Plus 5.
So my final answer
9 and 5.
is 9, 9 comma 5 as a point. How many had that answer? Very good. Okay? So one of the places where you can make mistakes in these problems. Okay? One of the ways that you can make mistakes is if you mess your signs up. This is going to be important. Please hear this. Please hear this. On a quiz, on a test, let's say you messed this up and you had x equals negative 9. But then you used that wrong answer correctly over here. I'm going to follow your work, and I'm going to see that you understand the concept and the process, and I'm going to give you most of the points. Okay? You're not going to lose all the points because you messed up a sign here and used that wrong number correctly over here. I'm going to give you most of those points. So this is why it's super critical that you show your work. Okay? Last example. This last example, notice here, okay, there's not something nice that I can multiply 3 by to turn it into a 4. I can multiply it by 4/3, but I don't think you want to do that. There's not something nice here that I can multiply 2 by to turn it into 5, unless you want to multiply it by negative 5 over 2. Okay? So in this case, what I recommend is this is 2c. You want to multiply both equations. Now, I could choose to eliminate the x's, or I could choose to eliminate the y's. Here's the reason I want to choose the x's. Anybody know why I want to choose the x's? Yes, Isabel.
Because don't they have a greatest common factor? That would be like.
Negative.
There's a negative and there's a positive. That's the reason. Okay? I already have the signs opposite here. The signs are the same, which means if I wanted to get rid of the y's, you can do that, and it's totally fine. One of your multipliers is going to have to be a negative number, though, because you're going to need one of these negative, and it doesn't matter which one. With the x's, I already have one of them negative, so I can multiply by positives. Now, the way that you do this is you go, all right, what number does 3 and 4 go into?
12.
It goes into 12. So what would I multiply this by to turn it into a 12?
4.
What would I multiply this by to turn it into a negative 12? Okay, so this is the situation here. So I'm going to multiply this top equation by 4, and I'm going to multiply this bottom equation by 3. So I'm going to get 2 new equations. But because I'm doing this, this will allow me to make the x's cancel. Okay, so why don't you go ahead and come up, just start with your 2 new equations first, and then we'll talk about what you got and then work through how to finish that problem. If you want to finish it, you want to try to finish it, you're welcome to try. So when I combine these together, well, I'm not going to combine them first. Let's multiply them first. So I get 12x plus 8y equals negative 8. And then I get negative 12x plus 15y equals negative 84. Okay? So I multiply the top equation by 4. I multiply the bottom equation by 3. Okay, now that I have this set up that the x's are going to cancel, I add the equations together. Okay, the x's go away, and now go ahead and finish the problem. So again, after we do the multiplication, it turns into a problem like 2a. It's set up for variables to cancel. Here, what's 8 plus 15? 23y. And what is negative 8 minus 84? Very good. What do I do next? Okay, so y equals negative 4. Okay? Now, here's what's important. Okay? You're going to have to plug that into an original equation. It doesn't matter which one. I'm going to choose to plug it into the first equation.
So you can take whatever one you want.
Either one. Okay, either one. Other thing that a common mistake is I'll see kids plug the first answer into the wrong variable. I'll see kids plug negative 4 into x instead of y. Okay, so be careful on that. Okay, so I have 3x minus 8 equals negative 2. So I add 8 to both sides. What is negative 2 plus 8? So what's x equal? Okay, so my solution is 2, negative 4. Okay. I have one other thing that I need to talk about quickly. Okay? One other thing that I need to talk about quickly. Address that. Okay? If you plug it into one of the new equations, so listen very closely, this is important. You know, if you multiply it correctly, then plugging it into one of these equations is fine. But if you make a mistake and you plug it into one of these equations and one of your equations is actually wrong, it's going to produce an answer that makes you think it's right, when in reality this first part is wrong, which makes the second part wrong. What will happen is if you plug it into one of the original equations, you will find out fairly quickly if you made a mistake. Because sometimes, like for example, let's say you had this as minus 8 instead of plus 8. You messed up there. That's going to screw everything else up all the way through the end. Except when you plug that number into one of the original equations, it's going to be easier to tell if you made a mistake. That's why I think it's really important to always use the original equation to plug into. The last thing I want to talk about is this can happen. Yep. It is possible that after your multiplication, when you combine together, it is possible that all the variables cancel out. Right? If that happens, you're going to be left with a situation like this. You could be left with a situation where you have 6 equals 6. You've done some work and you get 6 equals 6. Okay? Or you could be left with a situation where you've done all your work, the variables cancel out, and you're left with something like this. 0 equals 9, which of course it doesn't. If you have a situation like this and your answer is true, the solution is infinity. There is an infinite number of solutions for that particular system. Okay? If you eliminate all the variables and it comes out to be something like this that's false, then there is no solution. Okay, this means no solution. And this means infinitely many solutions. Okay? I don't think I assigned any to you that are like either one of those yet. But you will see that. Okay? Again, this is only true when all the variables cancel out. If all the variables do not cancel out, there will be a solution. Okay?